Howdy everyone, our team, the Groove Gurus, did an analysis on a band's jam session. Our team consists of Jackson Sanders, myself, Santi Garcia, and Batham Jayawardena. The agenda for this video starts off with a system introduction, and then we focus on the HTA, our data collection method, the survey findings, key problems that we noticed, solutions we identified, and finally, we will end it off with the conclusion. The purpose of the study is to analyze the sociotechnical cognitive aspects of playing music with a group of musicians. Our goal was to understand how social dynamics, cognitive processes, and technological factors influence the music-making process during collaborative music playing. By exploring the ways in which musicians interact, communicate, and create music together in real time, this study sheds light on the complex interplay between human cognition and social technology in the context of creative musical expression. Each of the members in this project were excited to undertake the study from both a personal and graduate student standpoint. We're excited to share what we found, and we're grateful for everyone who contributed in this project. To effectively do this study, we divided our study into 3 distinct categories: environment setup, practice, and the overall performance. The environment setup are all the external factors that influence a group. This includes the audience, the lighting, and sound mixing. The practice focuses on the events leading up to the performance. This includes how much time members played with each other and how often they practiced a song. And finally, the performance includes the rhythmic synchronization, melodic cohesion, and the overall setup that occurred during the performance. Now we'll be focusing on the hierarchical task analysis. The overall goal of performing a song is split into 4 subtasks. The first one is the environmental setup that focuses on the musician. This ensures that the sound, lighting, and instruments are set to the band's members' liking. The second is the environmental setup that focuses on the audience. This involves understanding the audience size and choosing music that the audience would like. The third subtask focuses on the band members' cohesion. And the fourth subtask focuses on the communication between members during the performance. Now I'll be handing it over to Patham, who will be talking about data collection.
Thanks, Rashad. We decided to go with the survey sent out to musicians who perform in a group as the method of choice for several reasons. Namely, that it was quick to conduct, that the survey software allowed for an easy aggregation and analysis of the data, and that we could include both open-ended and close-ended questions like free response and multiple choice, respectively. Some negatives to using a survey, however, were that it's not the most accurate data collection method, and that it relies on the recollection of events or incidents, often much later than they've actually occurred. To help counter the recollection issue, we employed the use of the critical incident method. The critical incident method relies on getting the respondent to tell us about their experiences with the system when something unusual happened. In our survey, this took the form of asking what their best and worst experience playing in a group was, as well as asking for a near-miss experience, where they saved the performance by doing some recovery action. By using this method and asking questions in this manner, respondents are more likely to descriptively recount these events, since best, worst, and near misses are more memorable. We also integrated this method into our more close-ended questions. For example, you can see with the graphic to the right that we asked, what do you find to be the biggest issue when playing in a group, in an effort to draw out the major and most memorable problem they encountered, rather than asking them to tell us every problem they had playing in a group. We also did not want to lock them into a few choices, so we gave an other option where they could add their own biggest issue. The insights we gained from these responses using the critical incident method were some of the most valuable of our data collected. I will now hand it over to Santi.
As a continuation from the data collection method, we will now discuss the major survey findings. We had a large amount of respondents report good performance when there were run-throughs for the song, when there was a leader, and when there was a minimum of 3 rehearsals before the performance, to name a few. Overall motifs for the survey were split into good and bad. Some of the good motifs were group flow and adaptability, while some of the bad motifs were tempo and technical difficulties. From the major findings, we were able to extract a few key problems. These key problems fall into three categories: setup, experience, and tune and tempo. Under setup, the interactions between these environmental components and the musician open up a world of complications. These interactions can be human to human, human to technology, or a mixture of both, leading to a seemingly endless potential for error. Regarding experience, we found that a musician's unfamiliarity with either the group they're playing or the song they're playing can lead to a slew of complications in performing cognitive work, which, in the scope of this study, is performing music. The third key problem prescribes the major struggles a musician may encounter while performing, such as maintaining rhythmic and melodic cohesiveness as a band. And to simplify this, we've coined it as the term tune and tempo. The categories of these problems may look a bit familiar, and that's because each corresponds to a component of our system introduction: environmental setup, practice, and performance. So now that we've taken a look at our key problems, what's next?
Before moving into anything solution related, let's take a look at how one achieves expertise in musical performance. Jens Rasmussen published a framework for human behavior and decision making in 1983, and it's held its ground as a facet of human factors ever since. Without getting into the details, there are three levels: knowledge-based behavior, rule-based behavior, and skill-based behavior. Let's explore each in the context of learning how to perform music. First, we have knowledge-based behavior. In this stage, a beginner musician is learning how to make the basic physical movements required to play the instrument. In the beginning, each aspect of learning can feel laborious and quite frustrating, whether it be finger placements, posture, or general hand-eye coordination. Then, at the rule-based level, basic principles of music theory start to kick in. It's important to note that theory can be picked up through formal training, such as reading instructional materials or taking lessons, or it can be learned experientially. This might look like jamming over a backing track and painstakingly figuring out which notes work over the key that you're trying to play in. And last, we have the development of skill-based behavior. You can view this one as the level at which you perform when you go on autopilot mode. In skill-based mode, you're drawing upon deeply ingrained knowledge and executing your musical intent with refined motor skills. Now that we've laid out a general understanding for how the brain processes the cognitive task of performing music, what do we do with it? With this knowledge and the key findings from our study, we hope to identify some solutions which optimize knowledge gathering, enhance rule formation, and promote skill-based behavior as often as possible. We've focused thus far on building up our system, understanding that system, and identifying problems within the sociotechnical system that is the jam session. Our primary solution, a real shocker, is to practice, practice, practice. You've heard the phrase a billion times, because it works. Rehearsals, especially in a group context, strengthen rhythmic synchronization and promote ease of melodic cohesion. These factors help musicians to understand each other's playing styles, bolstering group chemistry. Second, we have a few tips to strengthen stage presence. Touching back on the last section, remember that playing an instrument is in skill-based autopilot mode is difficult enough to achieve to begin with. Cognitively engaging and building stage presence mid-performance can be tough, but a couple of ways to set yourself up for success are designing a set list that fits your environment, and two, choosing venues that make sense for the theme of your band. Given you're not Taylor Swift and you don't have $100 million and a giant catalog of amazing songs to make the perfect show, but a few wise audibles can be the difference between an unmemorable show and an unforgettable performance. Last but not least, we have the implementation of tools and technologies. Delving into the world of musical tech isn't for the faint of heart, especially due to generally large learning curves. Starting with relatively simple tools such as a metronome for practice and a tuner for setup, so many problems can be avoided down the line. On the more complex end of the technological spectrum, we have in-ear monitors. These allow musicians to hear the mix they want to hear instead of what the environment projects to them on stage. Unless you've had time to acclimate yourself to such a tool, whipping them out for a performance can be problematic. Not so surprisingly, this brings us back to practice, practice, practice.
All right, thank you, everyone. Here are some key points from our presentation, and we hope you guys enjoyed it.